Today's engines are truly remarkable, not only for their power, design, or eco-friendliness, but also for their unwavering commitment to environmental sustainability. These engines have the potential to revolutionize the aviation industry, and these are just a few examples of what the future holds. Modern aircraft are powered by gas turbine engines that pass air through a series of stages where it's compressed, ignited, and then expelled. This process creates a high-pressure exhaust that is used to drive rotating engine parts and produce thrust. Each aircraft, especially the huge commercial ones, requires huge engine power to achieve liftoff and flight. For example, a fully loaded Airbus A380 can weigh over 500 tons at takeoff. Due to its weight, the aircraft requires 4 massive engines combining 300,000 pounds of thrust. Each engine needs to propel the plane fast enough to generate the right amount of lift to overcome the force of gravity. The way the engine creates thrust can be separated into 4 stages. First, the engine sucks in a large amount of air through a fan and compressor. A typical commercial aircraft usually takes in 1.2 tons of air per second during takeoff. The next step is for the compressor to pressurize the air and deliver it to the combustion chamber. Inside the combustion chamber, the fuel is mixed with the air to produce the bang, which is responsible for the expansion that forces the air into the turbine. When all of these stages are activated and work accordingly, then the engine reaches the final stage, which is blowing the air and fuel out of the exhaust nozzle, providing the thrust. Over the years, many engines have been built in such a way, but some have proven to be much more effective and powerful than others, producing more thrust. And with the incorporation of some more advanced technologies, they've managed to revolutionize the aviation industry. A key factor for airlines is having a powerful and efficient engine that can allow aircraft to travel longer distances with a lower fuel burn. The current leader in the engine industry is the General Electric GE9X. If you're already an aviation fan, you already know that General Electric has been a leading force in aircraft engine manufacturing, and their GE9X is no exception. This engine is not yet in commercial service, but it's said to be used on the upcoming Boeing 777X, which is the newest addition to the Boeing fleet. The engine is based on the previously known GE90 model used on the older 777 model, but the GE9X is far more powerful than its successor. It can provide 134,300 pounds of thrust at its maximum, a 5% increase from the GE90-115E model. The company says that this engine is the most fuel-efficient engine ever produced, producing fewer NOx emissions than any other GE engine. Due to using composite carbon fiber materials, the engine is 10% more fuel efficient than its predecessor without requiring a significant size increase. The debut of the GE9X has been set for 2024, meaning in a year, we'll be able to witness the sheer power and glory of this engine, and combined with the 777X, this will create an aircraft that is simply unstoppable. Rolls-Royce is another leading company that has proven its power when it comes to aircraft engines. When the U.S. Air Force decided to replace the outdated engine on their B-52H Stratofortress fleet, Rolls-Royce immediately took this chance and created an engine powerful enough to allow the B-52 to reach maximum performance. The Rolls-Royce F130 turbofan engine in a dual-pod configuration was created and is set to replace the TF33 engines that are currently fitted on the B-52 fleet. The testing of these engines mounted on the B-52 has begun. The company claimed that some tests performed in the early stages have already provided positive results. In the past few years, long before the F-130 could be fitted on a B-52, Rolls-Royce conducted their tests on a dual-pod engine, where they confirmed that the engine design and performance were a perfect fit for this fleet. The company has spent over 500,000 hours of digital engineering to further develop and refine the engine for the B-52, and today, it appears that they've managed to do just that. The engine can produce 17,000 pounds of thrust and is a variant of the BR-725 commercial engine. Rolls-Royce was awarded a contract in 2021 to replace the bomber's fleet's existing engines with more than 600 new F-130 engines. Currently, they're in the testing stage, which may go on for a few more months, but according to the company, things are looking bright. Soon enough, each of the exciting B-52 aircraft will be fitted with this engine, allowing them to reach their full potential. Pratt & Whitney is a company best known for the PW1000G, which powers the Airbus A220 and the A320neo family. However, there are 6 variants of this engine, which are all referred to as the GTF family. Today, the GTFs are installed on over 1,000 aircraft, providing speed and power unlike any other. GTF stands for Geared Turbofan, and the company has said that they have spent $10 billion on this technology to ensure it is the best on the market. What makes these engines different is that their fans spin much slower than the compressor and turbine, giving them a 12-to-1 bypass ratio, the highest in the industry. These engines also result in a reduction in fuel efficiency, noise, and emissions. The engine family is always upgraded with the latest innovations and technologies to receive the highest power and speed. Each engine in this family can generate 15,000 to 34,000 pounds of thrust. Pratt & Whitney believes that many improvements are still left to be made, but with the sheer power we've witnessed on the PW1000G, you can only imagine how much better the newer versions of this engine will be, and how many new technologies they'll include to make it even more efficient and produce less noise. Another new addition in the world of aircraft engines is the world's largest aircraft engine, the Rolls-Royce UltraFan. The engine is already fully operational and ready to be tested, but the company says that it will eventually hit the skies in airliners that are set to be developed in the 2030s. This turbofan engine is the first of what will become a whole family of engines ranging from 25,000 to 110,000 pounds of thrust. This huge engine is expected to provide a 25% leap in efficiency. The 140-inch diameter fan is around 5% bigger than the one on the GE9X, and currently there is no other turbofan engine bigger than the UltraFan. The UltraFan runs a planetary power gearbox between the fan and the compressors at the back, allowing it to run at its optimal slower speed while the compressors run at their optimal higher speed. In the early testing of this engine, the gearbox handled 87,000 horsepower, which is yet another aerospace record. The engineers have ensured that a large volume of air goes around the compressor core and straight out the back of the engine. This helps to cut down on noise by an impressive 35% and gives the engine a significant boost in fuel efficiency. CFM International has been a company that has stood out with its CFM56 engine, which has been described as the dominant narrow-body engine of the future. However, they didn't stop there. They created another engine that has blown everyone's minds, and an engine that is possibly the most revolutionary of them all. In 2021, CFM announced their new RISE program, or the Revolutionary Innovation for Sustainable Engines program. This program is set to produce the next-gen CFM engine by the mid-2030s. The company is currently developing the open rotor engine, which is said to be a complete game changer that will write a new chapter in aviation technology. This new engine may not be available for use for many years, but according to CFM International, it will be able to reduce fuel burn by as much as 20%. It'll be developed with composite fan blades, heat-resistant metal alloys, hybrid electric capability, and additive manufacturing processes. The RISE program includes over 300 separate components, modules, and full engine builds. When this engine hits the market, it's said it will be suitable for most aircraft being presented to both Boeing and Airbus as a replacement for their older engine models. We have yet to see what the future of the RISE engine will be, but it sure looks bright. Although this isn't exactly a new model yet to be released, we believe it deserves mention since it's among some of the most powerful engines in the world. This engine can be found on the Airbus A350 model. However, it also has 2 variants, which are the XWB-84 and the XWB-97. The XWB-97 is the more powerful of the 2 variants, offering 97,000 pounds of maximum thrust. It is powerful, and this engine is considered one of the most efficient engines ever built. This allowed the A350 to start a new generation of ultra-long-haul flights. The Trent XWB features a 2-stage IP turbine rather than a single stage from previous Trent engines. These engines are exclusive to the Airbus A350 family, but can easily be fitted on any wide-body aircraft. Today, flights of as few as 45 minutes and as long as 16 hours are powered safely and efficiently by the XWB. Its cutting-edge design and advanced technologies result in reliability, versatility, and unique range capacity. With the huge success of this engine family, Rolls-Royce is one step closer to designing an aircraft engine that will truly change the entire aviation industry. Bye for now.